Karl Popper, he's going to be very much a good empiricist. He's starting in the same place as the positivist, but then he's going to go quite different way. And then next week, we're going to see Thomas Kuhn, and Thomas Kuhn's going to go and he's going to give us a methodology for science, but it's going to throw all this out. He's going to say, nah, this whole project is deeply flawed. But we'll talk about them. Karl Popper is fortunately much easier to understand, I think, than people that we've looked at so far. If you understand this sentence, you basically got Popper. Insofar as a scientific statement speaks about reality, it must be falsifiable. And insofar as it's not falsifiable, it doesn't speak about reality. There we go. We're done. Have a good one. But I mean, we should talk a little bit about what he's got in mind. So, Karl Popper and Thomas Kuhn, this week and next week, easily the two philosophers of science that are most well known outside of the philosophy of science. Well, Kuhn has been incredibly influential amongst people working in the social sciences of science, and we're going to see a lot of that in the second half of this course. But historians, sociologists, anthropologists, people doing science studies in general have really been inspired by Kuhn and the work that follows after him. Karl Popper, by contrast, is at a similarly strong influence on actual scientists, on people doing physics and biology and chemistry. If you can get a scientist to sort of talk about like these issues, the sort of the fundamental epistemology of science, and you get them to care about these things, they'll probably side with Popper. They'll probably think Karl Popper has roughly what we have in mind. In fact, Popper's been so influential, like many of you are going to be school teachers. The kind of the default view, the thing that we teach in textbooks when we're trying to explain to kids what science is basically Popper combined with some a little bit of extra stuff that sort of is like a bootstrapping of the problems Popper's going to run into. But so he's been really influential in people just talking about and understanding science in popular culture, and actual scientists sort of trying to give an account of what they do. As your text notes, he's been knighted. His work has been used to settle scientific debates and legal debates about science. And he's still to this day championed by many scientists, particularly in the biological sciences. At the same time, his theory of science is almost universally rejected amongst philosophers of science. And so that'll be interesting to see why. And that's really what we're going to do today. What is his theory? Why is this so attractive? And then why do most of the philosophers working in this area think he's wrong? So who was he? No, we said at the outset here, right? He was he starts his career around the same time as the Vienna Circle, and he's in the same circles as those people. He's connected with them. He's friends with them, but he doesn't like the way they're going, right? He thinks that the logical positivist approach is doomed to fail. And when logical empiricism shows up, he thinks that project is also going to, run into walls. Like he doesn't think they're going to be able to solve the problem of induction. So he rejects both of those views. Well, that said, he's broadly an empiricist, but he thinks positivism and logical empiricism both won't work out. He incredibly bright man, and he was quick on his feet. He was well known to have a cutting wit, and he also had a very low tolerance for ideas that he thought were poorly supported or asinine. Your text notes he got into an infamous fight with Wittgenstein, in which Wittgenstein was so upset that he grabbed a fireplace poker and threatened Popper with it. Probably his biggest problem with the Vienna Circle and the logical positivists was he just found what they were interested in boring, right? They were interested in language and logic and meaning and knowledge, and he just had little time for that project. If Karl Popper was around today, he would be somebody like Timothy Caulfield, or the Mythbusters, or somebody like that. He'd be a person that was very interested in debunking pseudoscience. He was interested in what does distinguish science from pseudoscience. What is the methodology of the sciences that pseudoscience lacks? And that's what he wanted to give an account of. And his account is actually fairly intuitive, and it's fairly easy to understand. He focuses on falsification. He says scientists are not in the business of confirming or proving anything. And he didn't think that confirmations or proofs of scientific claims was ever possible. he thinks, and just go back to the problem of induction. Inductive reasoning does not provide a proof, right? Inductive reasoning provides support for a claim, but you can never prove something inductively. And he's just like, yeah, that's fine. Scientists are not trying to do that. What a scientist does, he says, is, if they're being a good scientist, is they tentatively assert. They say, here's my theory. And then once they've got a theory, they don't go out there trying to prove it. He says, that's impossible. You're never going to prove your theory is true. And he says, and you don't try to confirm it. That's what pseudoscience does. And I'll give you a bunch of examples. Think about the monolith behind me, right? And people that think these are from aliens. What are they doing? They look for confirmations. They look for reasons to think that these might be there from aliens. You think scientists don't do that. If you were a scientist and you want to know, is this monolith behind me put here by an alien? What you would do is you would try to falsify that claim. You would think about what kind of evidence would give me reason to think that this wasn't, it wasn't aliens that put it here, but something else. And you would design an experiment to see if you could falsify your claim. If you could, then you know your claim's false. And if you can't, you say, well, I tentatively assert this. But I assert it not because I've proven it or because I've confirmed it. I assert it because I haven't been able to falsify it despite my best efforts. So the scientist basically, for Popper, sits down with a table and he says, prove me wrong, right? But instead of telling you to prove him wrong, he tries to prove himself wrong, or she tries to prove herself wrong. And then he thinks that's what science is in the business of doing.